All right, so we're going to look at and use the binomial theorem again and do another expansion. So let's look at x plus 2 to the 6th power. So we're going to go ahead and start with the variable for x. All right, so I'm going to go ahead and do this vertically. We're going to go ahead and start off with the combinations. The first term is going to be 6 choose 0, then 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and the last one is 6 choose 6. All right, once I have the combinations written down, I will go through and do the x values, or the first term here. So that just becomes x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and x to the 0 power, which is just 1. Going back up in the other direction, we're going to do the y, or the second term. The second term here is 2. Now, if this was a sign there, you would include that sign if it was a negative. So that's going to be 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, and 2 to the 0 power, which is just 1. So this is just equal to 1, 6, 15, 20, 15, 5, and 1. Those are all our combinations. And remember, you can also get them from Pascal's triangle. And since this is raised to the 6th power, you have all of the same values in that 6th row of Pascal's triangle. So let's just go ahead and simplify with x's and with 2. And for x, that stays the same, so that's just going to be x to the 6th. This will be 6 times 2 times x to the 5th. This will be 15 times 4 times x to the 4th. This will be 20 times 8, that's because 2 to the 3rd is equal to 8, times x to the 3rd. That is going to be 15 times 2 to the 4th, and 2 to the 4th is 16, x squared, and 2 to the 5th is 32x, and the last one, 2 to the 6th, is 64. So if I go ahead and put this all together, I can go ahead and write that out as an expansion. All of that would equal x to the 6th plus 12x to the 5th plus 60x to the 4th plus 160 x to the 3rd plus 240 x squared plus 160x plus 64. Now, I won't always, and you won't always be asked to write out the whole thing. A lot of times you're going to be asked to write out a certain term. So when you're looking at these, remember this would be the first term, second term, third term, and so on. And there's a way we can go ahead and do that. All right, so the formula we're going to use for that is still going to start off with n, because you're still starting off with x plus y to the nth power. So it's n choose r minus 1. I take and multiply that times x. And think about this r minus 1 as a singular piece. It will help when we're doing this formula in a minute. So that's going to be n minus r minus 1 times y to the r minus 1. Because if I think about that as whatever that bottom number is here, so whatever that bottom number is, I subtract it from n in the exponent for the first term, and then is just that value as an exponent for y. Let's go ahead and do a question. I want to find the 8th term of the binomial expansion of x plus 2 to the 11th power. So I know that 11 is equal to n, and I know that the 8th term, r is equal to 8, so r minus 1 is equal to 7. And this is that number we're going to be using. So when I set up the combination here, I make that 11 choose 7. Then it is x to the 11 minus 7 power times my y term, which in this case my y term is just 2, and that is to the 7th power. So 11 choose 7 is 330 times x to the 4th. 2 to the 7th is 128. So all of that is equal to 42,240 x to the 4th. And this is the 8th term. Now, if you wanted to go through and do this with Pascal's triangle, which I know a lot of you do, remember n is equal to 11. That's what we have here. That means we have row 11. So we're going in this piece here, we're going all the way over. We're looking at this row. So whatever this first number after 1 is, that will always match up with the n value. And which number do you want in Pascal's triangle? In Pascal's triangle, you want the 8th number over. So this would be 1, 2, 3, 4, 5, 6, 7, 8. So that is why that value there is that 330. So I just have the formula for our binomial expansion at the top. And now we're going to go through and do that same thing again. We're going to try another example. So I want to go ahead and find the 3rd term of x minus 3 to the 6th power. So I start off with this, n is equal to 6. R is equal to 3 because I'm looking for the 3rd term. So r minus 1 is equal to 2. And I like writing it this way because r minus 1 is what goes in the bottom of the combination. I subtract it from n, and it is the exponent of r. So to go through and write this out, I get 6 choose 2 times x to the 6th minus 2. And in this case, y is equal to all of negative 3. So that's going to be times negative 3 to the 2nd power. All right, so to go ahead and finish the computations with this, if I have 6 choose 2, 6 choose 2 is just equal to 15 times x to the 4th times 9, or 135 x to the 4th. And if I want to go ahead and do this and look at this using Pascal's triangle, remember we are n is equal to 6. So this right here is my 6th row, and I want to go through and find the 3rd term. So this would be, this is the 1st, this is the 2nd, but I want to use that 15 because that is my 3rd term there. All right, so we're going to go ahead and do one more. I don't have the formula copied down here, but I think you guys can go ahead and remember. We know that n is equal to 5, and then r is equal to 4. But what we really need is we need r minus 1, which is equal to 3. So when I'm setting this up, I know the 4th term is going to equal to 5, and then that's 5 combinations of 3. Now when we do this one, we have to be extra careful because x here is not just x. X now is x squared. And I'm taking that to the 5 minus 3 power. Then I multiply that times y to the 3rd. So first part I have 5 choose 3. 5 choose 3 is just 10 times x squared raised to the 2nd power times y to the 3rd, or 10 x to the 4th y to the 3rd. And then if I want to go ahead and look how to find that coefficient, that 5 combination of 3 using Pascal's triangle, remember the first thing you want to do ahead and what n is equal to 5. So you find this row, this one right here, that where 5 is that 1st term. And then whatever your 4th term is, and the 4th term is just what r is, I go over and that would be 1, 2, 3, 4. So in this time I would want that 10, and that is why that 10 is there.